Now we are discussing about magnets and magnetic field. Let's start the session. First we are discussing about magnetization theory. The first point, an object becomes magnetized when atomic north and south poles align. All the materials have tiny magnetic poles called magnetic domains. What are the magnetic domains? Imagine one material that can be magnetized like iron or steel. Inside the material, inside of this material, there are tiny or specialized regions. These are called magnetic domains. You can think of each magnetic domain as its own miniature magnet. Each one has its own tiny positive and negative end. This is north and south end, just like a regular bar magnet. In an unmagnetized material, the domains point in random directions, so their magnetic fields cancel out. When we apply a external magnetizing force like a coil or a magnet, the domains turn and align in the same direction. So this align as the same direction. This is the direction. This is the magnetized material. If this is our unmagnetized material, these are randomly not organized. So this is unmagnetized material. When most domains are aligned, the material become magnetized and creates its own magnetic field. The next point is Earth's magnetic field is generated by the rotation and movement of its molten iron core. Our Earth works like a huge magnet. Deep inside, the molten iron core is moving and rotating, which creates a natural magnetic field. This field is strong and stable enough to be used for navigation. A compass needle aligns with the Earth's magnetic field and points toward the magnetic poles like north and south. Just like a bar magnet attracts a small metal needle, the Earth's magnetic field makes a compass needle point north. Next point, the Earth acts like a bar magnet with two poles. You can imagine the Earth as a huge bar magnet. This is the bar magnet, north pole and south pole with two poles, the magnetic north and magnetic south. Large ferromagnetic object like steel beams or pipeline, if left undisturbed for a long time and aligned with the Earth's field, can slowly become magnetized naturally. This is why sometimes a piece of steel may show weak magnetism even before we apply any test currents. The local magnetic anomalies. The Earth's magnetic field isn't perfectly uniform everywhere. All the Earth it's perfectly uniform, but it's not true. Earth's magnetic field isn't perfectly uniform everywhere. In some locations, the field is distorted because of natural deposits of ferromagnetic minerals such as iron or nickel in the ground. These changes in the field are called magnetic anomalies. They can cause a compass to give slightly wrong directions and in rare cases might have a small effect on magnetic particle testing. Example, if you are using a compass near a big underground iron deposit, it might point slightly off from the true north. The same disturbance could slightly affect magnetic inspections. So the next, magnetic fields A magnetic field is the invisible area around a magnet. So if this is a magnet and this is a invisible area around a magnet or an electric current where magnetic forces can be felt. The magnetic fields created by permanent magnets and electric current in a conductor. If the permanent magnets have fixed north and south poles and keep their magnetism for long time, and the electric current in a conductors, they have no fixed polarities, produces a magnetic field while the current flows. In some cases, the magnetic field can be confined entirely within the ferromagnetic object, so it doesn't spread out much. So what are the types of magnets means? One is permanent and another one is temporary. Permanent magnets keep the magnetism without an external power source for long period, without external. And temporary magnets only stay magnetized while a magnetic force is applied. When we are applied the magnetic force, they are magnetized. This is a temporary magnets. The next one is poles and forces. Magnetic attraction is strongest at the two poles like north and south poles. Like poles repel and opposite poles attracts. The next topic is detection of discontinuities. In magnetic particle testing, the part is first magnetized. Which part? This is first. This is the part. This is first be magnetized. Then the particles, that means the magnetic particles, are applied to the surface, dry or liquid suspension. If there is a crack or defect just below on the surface, the magnetic field will leak at the point. So the particles gather at the leakage field, forming a visible indication of the defect. These indications are then compared to specification limits to decide if the part is acceptable or unacceptable. What is that specification limits? That is the acceptance criteria code available in code or standard like ASME, API. These are. Then next one is magnetization can be induced by contact with magnetic material when we are using a permanent magnet. So permanent magnet. Next one is passing electrical current through the object around the object to create a magnetic field, passing the electrical current. Next one is vibration or impacts can cause a temporary magnetization in some cases. All magnetization methods work by aligning the magnetic domains inside the material. So inside the material, the magnetic domains are automatic aligned. So they point from north to south. It creates a strong magnetic field. Thank you. We will see the next video.